I will discuss those theory on that, and then we will see how we process all these things on R. So whatever I am going to discuss, let me clearly mention that these things have been taken from these sources. These all the sources from where I have taken the things, and I have prepared my lecture. So the, the random forest, before understanding the random forest, we have to first understand the decision tree. And before understanding the decision tree, we must know about machine learning. So many of you must be knowing about machine learning. So what we are going actually, and what we are doing in machine learning, based upon some input, we develop models which will be used in machines. So our machine improves in decision making. That means we are actually using artificial intelligence to train our machine. Basically, we are training some model, because machine is not going to train. Some software, some models are we are training. So for that we have a data, that means input, and when we train something, we have to verify it also. So we verify it by dividing the data in training set and test, which I have already discussed. So in machine learning, there are three kind of learning. One is the supervised learning, supervised, and second is unsupervised, and third is reinforced learning. So you know that I am not going to discuss these things in detail. Okay, supervised learning means in which we have a response variable which we have observed. So with the help of observed response variable, we will check whether our model is good or not. So that is supervised learning. In unsupervised learning, the response variable, we do not know what will be the final response, what will be the answer, that we do not know. In that, we are going to unsupervised learning. And reinforced learning is similar as we human beings learn. That means we we collect data and we improve one by one. That is the reinforced learning. So in these kind of learning, our two main aims are the classification, and another is regression. Okay, basically classification, as I have already discussed, that we have some item and we want to classify it into different groups. In regression, our output variable, in general, we are focusing upon that our output variable is in a simple manner, which people understand, that output variable is continuous and we want to predict it. So you have seen that in logistic regression, your output variable was categorical, but we have converted that output variable in log odds and made them in continuous kind of thing. So in classification, in machine learning, we have naive-Bayes classifiers, we have logistic regression, we have decision tree, and we have a random forest. We can use them in regression too, depending upon how we are using it. So I am not going to cover, of course, naive Bayes. Logistic regression I have already covered. Decision tree I have to cover before random forest. So what is decision tree? We are going to discuss that briefly. Okay. So in a decision tree, what we do actually, see, it is very simple. There are lots of simple examples. For example, if you have in your basket, uh, if you remember that you have some kind of vegetables. Okay, for example, you have broccoli, you have carrot, and you have oranges in a basket, and you have to classify them. You means there should be a model, there should be something, some machine which can easily separate them in different categories. So now we want to do that. So there is I'm just discussing what is a decision tree and how it works. Then we will see some more examples which are complicated one. See, all of you know that this is of green color, and these two are of orange color. Okay, so if I start with the color, that means if I start with the color and I ask, is it colored orange? If I ask this question, if you say yes, and you may say no. So if you are asking this question, whether the color is orange or not, you can easily see when you say yes, the possibilities are carrot and oranges. If you say no, that means broccoli is there. So now if you see, you have clearly separated the broccoli easily. Just asking one question, is it colored orange? And based upon the answers, you have clearly separated broccoli. Now remember, if I ask a question, is it green? Then also we will separate it. So question may change, but the idea, just understand the idea. Now, but again, I want a question. I want to ask a question, which is it r- is it round? If I ask this question, again the answer may be yes and no. So you can easily see, if I ask, is it round? Carrot is not round. So oranges are round. So answer will give you oranges. And here we will we will have carrot. So you have separated all these things. So now this process which I have performed here, this is called decision tree. Okay, this is called decision tree, and with the help of decision tree, I have separated all these things just by asking some questions, and based upon answers I am separating these things. So you are taking decisions by asking questions. So this is an example of, this is a simple example of decision tree. Okay, I am not using some very complicated example. It is a very simple example. Now this example which I have used here, it is used in classification, because I have classified oranges, carrot and broccoli in separate group. So this is example of classification. The same decision tree can be used for regression purpose, that means for prediction purpose. We will see in examples. So when you use them in regression purpose, what we will do, actually we will take the uh, final output, and we will see the majority vote belongs to what. That we will see in detail, but there are some terminologies which we must know. First is nodes. First is nodes. So wherever there is a split, so if there is a split, that is node. So you can see here, here is a split, yes, no. So this is a node. Here is a split, yes, no. This is a node. Here, so these are the nodes. And the first node is known as root node. The first one is known as root node, that means the top one. And there is a leaf node, that means the last one. These are there is no split further, but these are the outputs. So these are the nodes. These are called leaf nodes. This one, and this one. These three are leaf nodes. That means the output or whatever at is at end. Now, question is how we uh, decide how we decide that we should start from question colored first, or we should start for this question round first. See, you can see I have asked two questions: is it colored orange, is it round? So it may be other way also. I should ask, is it round first, and then is it colored last? So which questions should be asked first? That may be the next thing. So in statistics or in machine learning, how we convert these things, see, these are features: x1, x2, and xp. These are the features means by which you are going to decide. So here, see, feature, in this case, this is color is one feature, shape is another feature. So here in our example, we have x1 and x2, only two things are there. So we want to know whether we should use x1 first or we should use x2 first. If there are p features, which feature we should use first? This is the first thing we want to know. And second, how we split all those things. So these two questions are there. We want to know about these two questions. So these two questions will be answered based upon an idea of entropy. There is a concept of entropy. Concept of entropy. So it simply, that means without any mathematics, if I focus upon the concept, it is a measure of the messiness of the data. Messiness means data heterogeneous. If data is extremely heterogeneous, entropy will be high. If data is homogeneous, entropy will be low. That is the idea. How we calculate entropy, that is another thing. But we must understand the idea that entropy is actually measuring the messiness of the data. That means the heterogeneity of the data. So if I ask you in this example, if I ask you, when you have data at this point, that means you have broccoli, carrot, and oranges, entropy will be high. When you have broccoli only, entropy will be low. When you have carrot and oranges, entropy will be low in comparison to the previous node. But it will be the bigger entropy in comparison to oranges and carrot separately. So that means when you move downwards in a tree, entropy must reduce. That is the first idea. When you move from above to lower side, entropy must be decreased because you are classifying it. So heterogeneity must not be there. That is the idea of the entropy. How? So we choose that variable, that x1, x2, or xp, out of these we choose that variable which reduces entropy more than other variables. So here color and shape. So color and shape, if color reduces more and reduces more entropy in comparison to shape, we should use color first. If shape reduces entropy more in comparison to color, we should use shape. So it depends upon. So this is the choice we will make in when we develop our model. Remember that the idea of entropy, we want to reduce the entropy, and we choose x1, x2, xp, and their cutting points based upon these things. Okay. Now, if there is two entropy, E1 and E2, and you take the difference, this is called information gain. Information gain, and we assume here that E1 is greater than E2. So you are getting positive information gain. If it is negative, that means you are losing. But you can see in decision tree, if we are moving forward, it will be the case. So E1 is the entropy of the first stage, E2 is the entropy of the second stage. So we want to know E1 minus E2. That means what information we have gained. So if it is more, E1 minus E2 is more for color in comparison to shape, we would choose color. Otherwise, we would choose shape. That was the idea. So these things we will use frequently. Now I will show you one another example in which we will calculate the entropy also. So there is one more example in which we have these things. Just to understand, because R will do everything very easily. Concept be understood before going into software. This is my belief. So I always try to fix first the theory, then computer, because computer will do everything if you write down code. So shape, round. What I am doing actually, we have data of ball, we have books, we have cards, we have blocks, and these four things we have. And features are round feature. You can see ball is round off, and all others, all other are rectangle. All other are rectangular. You can easily see. Size 10 centimeter diameter kind of thing, or whatever. 6, 4, 2. Label is, this is ball, this is book, and this is card, and this is for blocks. And number means how many of them are present in the basket. So these are the number which are present there, and this is the total. Now I want to develop a method by which I want to classify these things. That means I want to classify ball separately, book separate, card separate, and block separate. And I know only these features and something. These features we know that whether they are what is the shape, what is the size. These two things we know, and how many of them are there. Now, how to proceed? The first question is we have to start. So at the starting point, we will have all the 9 items with us. At the starting point, we will have all the 9 items with us. Now I have to ask a question here. I have to ask a question here so that I can separate them, I can classify them. But the thing is, I have to ask a question in such a manner that we have to, excuse me, which will reduce the entropy. So we have to calculate the entropy. So here we calculate the entropy, and the formula for calculating the entropy is minus summation of pi log base 2 pi. What are pi? I will explain. And this I is from 1 to whatever items you have. So we have, sorry, whatever items, no, we have whatever labels you have. So we have 4 labels. We have 4 labels. So this is the formula for entropy. Entropy is equals to minus of summation pi log 2 of pi. That means it is basically minus of p1 log base 2 p1 minus plus of p2 log base 2 p2 plus p3 log base 2 p3 plus p4 log base 2 p4 in this example. This is the formula for entropy. Now, what is P1 actually? So, P1 is nothing but how many items are there of first kind, proportion of that. So, here in this example, if I choose ball as the first one, so there are 9 items, out of which 2 are balls. So, 2 by 9 is actually P1. Log of base 2, 2 by 9, yes, we have to write down, plus how many books are there? There are 2 books out of 9 in the first stage. I am saying this is the E1. E1 means at this stage. E1 means entropy at this stage where all the 9 items are there. So this is 2 by 9 because balls are also, books are also 2. Log base 2 by 9. This is minus with a minus sign outside, plus how many cards are there? So there is 1 card only out of 9. So this is log 2 1 by 9. And how many blocks are there? There are 4 blocks. So this is 4 by 9 log of base 2 4 by 9. So this is the entropy at the first level. Now you see, I'm not going to calculate these things, but if you see, if the calculation is correct, if my calculation is correct, it comes out to be 1.8282 kind of thing. Okay. Now, what we are going to do actually, so we know that E1 is this. Now we are going to ask a question, and then we will find entropy at second level. So we ask all the possible questions, because we may have 2 questions. One is based upon shape, one is based upon size. We want to know whether we should start from the size or we should start from the shape. So if you start from the size, then you will have some different bifurcation. If you start from the shape, you will have some different bifurcation. So based upon those bifurcation, you will have entropy at the second level. Okay. So if you calculate entropy at the second level, it comes out to be 17384 for shape. And for color, it will be something else. So this is reducing a much thing. So these things the computer will do. I wanted to explain what is entropy here basically. So if I ask a question here, that what is the shape? So based upon shape, I am going to ask a question: is it round? I am asking this question: is it round? So when you ask this question, you can easily see if the answer is yes, you can easily get ball, because only ball has a round shape. And if the answer is no, you will get book, you will get card, you will get blocks. Okay. So this is the first question. And it depends upon entropy. So you can verify or calculate these things. Now I want to ask second question. I want to ask second question here. So what is the second question? Now if you see, second thing is based upon shape, sorry, size. So size is 10, 6, 4 and 10, 4 and 2. So if I ask just that size greater than 5 or not. So size greater than 5, if you get yes, you can easily see in size greater than 5 we have two things. One is ball and another is book. So we get ball, we get book. And here we get card, and another thing was block. So if you ask further question that size is greater than 3, so you will further uh, bifurcate these things, and it will be so on. So the thing is, we are doing two things here. One is one is which feature you are going to use. Another is cutting point. Cutting point. See, in this case, cutting point is a number 5. Here it is a round kind of thing. So we need these two things. And when we develop a model, these two things will be selected based upon we will get, and the criteria will be that we want to get higher information gain. This was the basic for the decision tree. Now, how you perform decision tree on R, all those things are different. So, if this is a book, The Elements of Statistical Learning and Data Mining by Hastie and others. This is also a good book. It contains the theory. I am not going into theory right now. First, I will discuss random forest. Before discussing random forest, I must show you decision tree examples. So, for making the decision tree, we have some packages which we will be required. So I have already installed these packages, so I'm not going to run these commands again and again. So you need a data sets package from where we are going to take the data sets. Then there is a package CA tools. Then there is a package party. This party package actually creates the tree. Then you will have DPLYR package and these packages. So these packages you are required for different purposes. Some of them may not be used in this lecture, but these packages are required. Then you import the libraries. You know how to import the libraries. So you import all the libraries. Then I am actually going to use a data which is saved in a file reading skills data. So this is the data I'm going to use. And if I want to see the heads of the data, that means some numbers. So these are the heads of the data. You can see it contains actually scores of some exam. It contains scores of some exams based upon some language exam, based upon whether a person was a native speaker of that language or not, and what was the age of the person, and what was the shoe size of the person. Now you can easily understand shoe size will not have any impact on that, but it is one of the feature. It is one of the data which we have. So we have 4 columns. Speaker, that person knows that language or not very well. What is the age, shoe size, and score in the test. Now, what we want to, 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 classify whether a person is a native speaker or not. So we want to classify whether a person is a native speaker or not based upon age, shoe size, and score. Now we will see whether these things will classify it or not, and how they will classify. So we have three features. One is age, another is shoe size, third one is the score. These are the three features which we have, and we want to predict native speaker. How you predict? Now we are going to run the model. So we fix the seed. You know why to fix the seed, so that we can, whenever we run the commands, we will get the same answer. For that, we fix the seed. So set the fix the seed. Then in machine learning, we have a data. Now what we do, we split the data. We split the data into two parts. One part will be used for training our model, and another part will be used for testing our model. So here I am going to take 80% of the data, 80% of the data for training set, and rest of the 20% for testing set. So what are the commands? Command is sample data, sample.split is the function, and then reading skills, that means the data file, and then split ratio. So split ratio I have taken 0.8. That means 80% of the data I am going to take in our sample. Then we define the training data. So subset, it will be a subset, of course, it will be a subset of reading skills, and whatever in the sample, that means sample data is equals to true. So this is actually our training data, and if sample data is equals to false, that means it is false, then this will be our test data. So we have taken the sample data, we have trained data, we have test data. Then now how to create decision tree. So the command is ctree. Ctree is the command to create decision tree. So what is the command? We are going to save our decision tree in model, and the command is ctree. In bracket we write down the model. See, we are writing the model native speaker tilde dot. Native speaker tilde dot. Dot means the period. That means we want to predict native speaker with the help of all the features available in the data. All the features. I am not writing the model. I am writing the dot. Dot will contain all the features. And the data is trained data. I am not taking the original data. I am taking the data is trained data. So in the trained data, the model is native speaker will be predicted with the help of all the features available. In our data, features are age, shoe size, and score. Okay. Now if you run this, it creates the model, and now we plot this model. So when you plot this model, see the plot on the right hand side. It is taking time. See the plot. Just wait. It is plotting the data. It is preparing. So after installing the package, call the libraries, and then call the data. See the head of the data, is fix the seed, sample the data, train the data, and test the data. Then define the model, and then plot the model. So this was the plot of the model. So you can see here on the right hand side, we have first node. First node means the root node. In root node, we are focusing upon score. We are focusing upon score. Remember, we had see on the left hand side, we had age, we had shoe size, and we had score. So which age is one feature, shoe size is another feature, score is another feature. Now question arises, which feature I should use first? So this program has decided to use a score first because a score will be reducing entropy much more in comparison to other two features. So it says that if a score is greater than 38.685, put the data on the right hand side. If it is less than or equal to 38.685, ask another question, that what is age? Whether age is greater than 6, you have this data, and age is less than or equal to 6, you have this data, and again ask question on the score. Score is greater than this, you have this data, and score is less than this, you have this data. So you can see this program has only used score and age. It is not using shoe size, because shoe size is actually irrelevant. There, there will not be very big impact of shoe size. That's why it is not using this. Now, what are the outputs? How to explain the output? You can see the last one, black and white. So black means yes, white means no. Yes represent here it is a native speaker or not, and gray, which I am saying white, is about the no. That means on this node, on this leaf node, there are mixture of yes and no. This third node, there are mixture of no. There are no, that means all are no, native speaker. And in the second one, all of them are of yes. In the first one, all of them are of no. So in the last one, only the mixture is there. But on all other, it is clearly classifying yes and no. It is not further, it is not further classifying, because we have to stop somewhere. So this program has stopped here. Okay, clear? Now, if we want to predict something, how to predict in this example? See, if you have something new of this kind, for example, this is the data. You just ask questions and see whether it belongs to. That will be the prediction. That is the idea of the prediction. So this was the how to prepare decision tree. But now, after preparing the decision tree, we have two things. We can use decision tree to classify as well as for prediction purpose, that means for regression purpose. So for classification and regression purpose, we have different things. For classification, we are using something else, and for decision tree, for regression, we are using something else. So I will show you two examples of decision tree, then we will move towards the random forest. Two more examples. One is decision tree as a classifier. Okay, that means now we want to predict as well as we do not want only this thing, we want something more, some better packages we are going to use. So for that, I read the data, and we have a data in I have a data of this kind. We have user ID, we have gender, we have age, we have estimated salary. These things are here, and one more package. One variable was, there was one more variable. वो कहाँ गया? There was one more variable. What? Yeah, there was one more variable, purchased. So what it is, it is actually there is a marketing company. There is some product, and those are actually noting down gender of the person, age of the person, estimated salary of the person, and whether that person purchased the item or not. So if it is purchased, it is 1 represented by 1, otherwise 0. So we have a data of this. So we want to predict whether a person will purchase something or not. That means we want to develop a model based upon gender, age, and estimated salary. User ID is nothing, that is not a feature. So based upon gender, age, and estimate salary, we want to predict the purchase behavior of a person. Okay. So now we want to focus upon data set purchase. We have factorized it as 0, 1. Then we are again splitting it. Now we are going to use CA tools package, fixing seed. We are splitting, split ratio I am taking right now 0.75. That means 75% of the data cases will be used for training, and remain 25% will be used for testing. Now, when you want to use a decision tree for classification purpose, we need this package, R part, classification or regression purpose, whatever, R part. So you have to install this package, and then we call this library. Now see the formula, classifier in which we are going to save these things. Now there is R part. This is the function. Now we write down the formula. So again the formula is same. We want to predict the purchase based upon all the features available. So we write down purchased tilde period. Then data is equals to training set. Then I am writing method is equals to class. Method is equals to class represent that I want to focus upon classification. If you do not write anything, classification will be the default one. So here I am writing method class. If I run this, there will be no output, because what it actually doing, it is classifying and saving it all the information in classifier. Now after saving this information, I want to predict our test data. That means now I have developed a model. Based upon model, I am going to predict the test data. So why predict? That means I am going to save the prediction in the variable y predict, and the command is predict. What you are going to predict? I am going to predict test set based upon the classifier which we have already developed in the previous line, and type is class. So you run this, this will predict the data. After predicting the data, it is not showing you anything. Now you know you had original data and you have predicted the data based upon this classification tree. So you must have correctly predicted, or you may have wrongly predicted. So you must have a confusion matrix. Now I'm going to draw the confusion matrix. So confusion matrix is a table. Of course, it is a table. Table of what? Test data of purchased. See, remember this is the original data. That means you are asking for the purchased variable, purchased column of the test data, which was the original data which you have observed, and y predicted. That means the predicted data. You are just writing down the table of between these two data, and it will give you the confusion matrix. And confusion matrix looks like this. See here on the left hand side, 0 1 0 1. So 0 56 times predicted correctly. See what confusion matrix is telling us. 0 correctly predicted 56 times and wrongly predicted 8 times. 1 correctly predicted 30 times and wrongly predicted 6 times. This is the confusion matrix. Now from the confusion matrix you can find out those things, accuracy and all those 4 things. Now if I want to see this classifier, that means this tree, I want to see, the command is plot classifier. So when you plot classifier, And when you write down text classifier, then it will show you everything. So see now, it is our classification. It says that first you use age less than 44.5. Then you use on the left hand side, estimated salary less than this number, and classify 01. Similarly, you again ask age, then estimated salary. So this is the classification which this program has done. And with the help of this classification, this program on the testing set gives this confusion matrix to us. Okay, so this is for classification. Okay, now there is one more thing, which is when we want to use the same idea, same tree idea for the regression, that means for predicting a variable which takes continuous value. See, in classification, it is taking value 0, 1, binary kind of thing. But if it is taking value continuously, for example, age, for example, salary kind of thing, then how to perform the same thing for that kind of response variable? So I am using the iris data, very famous data collected by the Professor R.A. Fisher, a great statistician. Professor R.A. Fisher, I hope all of you must be knowing him. So this iris data he had collected, and this data is basically, I will show you the data. So I will show you the data. This is the data. This data contains three types of flowers species: setosa and versicolor, and the third is virginica. So three types of species are there of a flower, and they have collected the sepal length, sepal width, petal length, petal width. So these four features have been collected and species are there. Okay. So now I want to predict. I want to predict this species with the help of. Oh, sorry. I have just. Oh, I have gone through random forest. Sorry, this file is related to random forest decision tree regression. So I have already installed plot. The data is same data I am going to use. I am going to use the same data. But now, since I want to use this data and tree for regression purpose, so for regression purpose, if I wanted to predict species, I have to use classification. But I want to predict something else. That means, for example, I want to predict sepal width. I want to predict sepal width with the help of sepal length, petal width, and species. So I want to use other four to predict sepal width. We can predict species with the help of other, but since I wanted to use sepal width, remember that this is not a binary data. It is a continuous kind of data. That's why I am writing methods is equals to ANOVA. Methods is equals to ANOVA means I am going to use a regression kind of thing in the tree. Remember, all other things are same. All other commands are same. See here, when you use here, the commands are same. Classifier, you see, R part, there is a formula, there is a data, there is a method. Here in decision tree, R part, there is a formula, there is a data, and there is a method. All other things are same, only the difference is in ANOVA. So if I use this, I run this, then you can save this figure. I have saved the figure. Now I can show you the file. The file was file deck tree. Where is the file? This is the file. So this is the decision tree for this regression question. See, this I have to zoom it. I have to zoom it. See, it says that first it focuses upon species, then it focuses upon petal length, then it focuses upon petal width, then it focuses on sepal length, petal length, and all those things. Based upon that, it is actually describing the uh, this one width. So now you can, based upon this, you can predict the width. Where is the width? Now, how you predict it? That is the question. So if your data satisfy this node, take the average width of all these items present here. See, in this node, for example, you have 5 items. See, it says 36. So you have 36 items here. You just take the average of width of those 36 items if you want to predict the width. Remember, now we do not have 0 1 kind of thing. Now we have a combination. So just take the average of all those. If you have 0 1 kind of thing, take the majority vote. That is the idea here. So if I, for example, if I want to uh, create test data, I am defining a test data. Species versicolor, I am fixing length 5.1. I am fixing petal length 4.5. And petal width 1.4. And I want to know what will be the sepal width based upon this model which we have developed. The predicted value is 2.80 for this particular data. So how to predict it? The answer is the simple: predict, fit, df means the data which you are entering, and method is ANOVA. So you have predicted the data. So this was uh, for the using decision tree as a regression. Now the last one is the random forest. What is a random forest and how we perform it? So random forest, if you focus it, it is based upon two things. Two things are there: random plus forest. Now you can understand, if I am discussing about tree. So if you have many trees, that will be a forest. And what is random? Random we are going to see. So now I will show you what we are doing, then we will read it. So what we are having actually, see, you will have, always you will have x1, x2, and xp. That means you have features. You have features here, and here you have 1, 2, for example, up to capital N. You have cases. Cases means data. This is the data. So here you have first data, here you have second data, you have nth data. Okay, so this is the data you are having. Now based upon this data, you can use the algorithm which we have used for tree, and you generate a tree. You can generate that easily without any problem, but you are generating just one tree. So one tree may overfit the data, and this has been seen that that one tree may overfit the data. One problem. This is the one problem. Second problem: this tree is based upon this data and these features. Now what we are doing actually, why this is called random forest, and what we are doing, we are doing two things here. One is we are generating, so instead of generating a tree, a single tree, what we are doing, we are generating many data points. See, what we are doing, we are taking simple random sampling with replacement. See, this is the whole data. You randomly select, you randomly select capital N data sets. For example, 1 has been selected, 2 has been selected, 2 again has been selected, and 5 has been selected, and capital N has been selected. Okay, so you see, from 1 to capital N, we take a simple random sample with replacement, means 2 can be repeated, 5 can be repeated, or any data can be repeated. This is the first step. So here we are using random algorithm. So you can choose many, you can choose many uh, data sets, many simple random samples with replacement from this. And then on this data, you run a tree. But now what we are going to do, now we are going to generate trees based upon, what we are doing, based upon m of the features out of p, m of the features randomly selected. आप समझिएगा. Now you see the thing. Now I am going to generate trees based upon m features. That means I am not going to take all the p features. Now I am going to choose, for example, I am choosing x1, e.g. I am choosing x1, x3 and xp if m is 3. And we will do it at each stage. Each stage means each node you have to choose this. So now you see, you will have many trees, and from each tree you will have leaf nodes. Now we will average out leaf nodes. If we are focusing upon regression, we will take majority of the votes from leaf node. If we are doing classification, so in the random forest, the main thing is, what we are doing, we are using the data again and again. We are using the data again and again. That means we are taking the samples from the data, and we are performing these things on different features. Why we are doing these things on different features? If some feature is not very significant, it will not give you many things. So for example, in this tree, if I have used x1, x3 and xp, and feature number x2 is not significant, so feature number of x2 in all these trees which does not contain x2, the prediction will be almost similar. So we will have many things, and now we will see the theory. I have explained the theory. This was the basic theory. Randomness is doing on the row. On row we are doing randomly, and on column we are also doing randomness. On row we are taking simple random samples, and then we are choosing the features. So now I am going to read it out, and then we will see this on a R. So random forest in R programming is an ensemble of decision. Ensemble, the meaning of this word, ensembles of decision trees, means you will have many decision trees working together. Ensemble means working together. They are working together for classification or for regression purpose. So we have an ensemble of decision trees. That means all the decision trees, they are working for us So it builds and combines multiple decision trees to get more accurate predictions. It's a non-linear classification algorithm. Each decision tree model is used, each one is used when employed on its own. An error estimate. Now question is, which model? If, for example, you are using x1, x2, x3, and you are leaving all other features, so your model will have some error. So how you calculate that error? So an error estimate of cases is made that is not used. That is not used. Okay, that is not used. For example, if I have choose 1, 2, 2, 5, and so on. Now you may understand some cases may not be included here. Some may not be included here. For example, 3. For example, 3. For example, 3 is not included. Okay. So an error. So there will be error for 3. So an error estimate of cases is made that is not used when constructing the trees. That means what we will do, we will predict this item. We will predict this item and see what is the error. So this error is known as out of bag, OOB in short, OOB error. So here we estimate OOB, and of course, if OOB is less, our random forest is performing better. Now, one thing is this, and why we are calling random? I have already told you that they are called random because they choose predictors randomly at one time. They are called forest because they have multiple trees. So random forest outperform decision trees as a large number of uncorrelated trees. Why these are uncorrelated? Yeah, this is the main thing. Why these are uncorrelated trees? Because in every tree, we are using different features. So when you use different features, different features, the correlation will reduce. So it is not uncorrelated, they are actually decorrelated. That means reduced correlation is there, and this outperforms. So what in theory, that means what is the algorithm? So this is the algorithm which I have already explained you. Random forest takes random samples from the observations. That was the first stage. Random initial variables, that means columns. So see, random sample means you are focusing upon rows, and then random initial variables, that means you are focusing on columns. So randomness is there in rows and as well as columns, and tries to build a model. Random forest algorithm is as follows. See, draw a random bootstrap sample. The term is bootstrap sample. Bootstrap sample means bootstrap sample means simple random sample same size and with replacement. See, same size means if you have capital N items in your sample, you must have capital N items. Same size means that you cannot reduce the number of items. The number of items may repeat themselves. That means some item may be outside the sample, but total number of items, for example, in your original data, if you have 100 data sets, if you have 100 cases in your sample, you must have 100 cases. Remember this one. Some case may repeat, that is okay. So that is the bootstrap sample. So draw a random sample of size n, same size, randomly chosen. Grow a decision tree on this. Now, how to grow the decision tree? At each node, that means at each decision question, you select randomly D features. You cannot use all the features. You are not going to use all the features. You select a bootstrap sample. On that, you run a tree by selecting D features out of available features at each node. Remember, at each node. For example, if you have 4 features, when you decide at first place, you can use 2. When you decide at second place, you can again use 2. You cannot change that. Split the node using features variable that provides the best split. What is the best split? Best split means by maximizing the information gain, which I have already explained you. That means which reduces entropy maximum. And then repeat all these things up to k times. K means up to how many branches you want to know. You want how many branches. Repeat all these things and then aggregate the prediction by each tree for a new data point to assign class label by majority vote. Remember, that means if you want to classification, for classification, we focus upon majority vote. Remember, that means all the trees you will have you have output from all, prediction from all the trees, and if it is a classification, you will have predictions of this 0 1 type. So if there are majority of 0, classify it as 0. If there are majority of 1, classify it as 1. Otherwise otherwise you have to see the average. That means in regression take the average. Take the average. Take the average. So this was about the random forest. I summarize it very clearly, quickly. In random forest, what we are doing? We have a data. From data, we take a bootstrap sample. That means a simple random sample with replacement of same size. And on this bootstrap sample, we grow a tree by selecting fixed number of features at every node randomly. And from all those trees, we take the majority voting for prediction in classification, and we take the average for regression. Now we see example. The same example of the iris data. So I have shown you the iris data. Now what we are going to do, we are going to use this package. CA tools I have already installed. There is another package which is random forest. Excuse me. So we have to install this package. After installing this package, use the library. Now split your data, because I want to do that whether prediction is good or not. So split your data. I have split it 70-30%. Train your data. Select your training data. Select your test data. Fix the seed and classifier. Now random classifier. This is the command random forest. Now see, this is your data. This is the iris data. It contains 5 columns: sepal length, sepal width, petal length, petal width, and species. So 5th column we want to predict. So that means we do not include 5th column. So from the training data, exclude the 5th column. -5 means you are excluding the 5th column. So this is your data. X is your data. Okay. So you are using just train without the species. And what you are predicting? You are predicting train species. That is your Y data. You want to predict species. And I am using 500 trees. That means how many trees you are going to use? So in this random forest, I want to use 500 trees. Okay, so you can use 100, 500, 1000, depending upon your choice. So 500 trees I am using here. So run this. After running this, run this classifier RF. So when you classify RF, it will give you this estimates. See, these things it will give you. OOB estimate error rate is 5.56. So this is the estimate error rate. Confusion matrix. It is giving you the confusion matrix. See the confusion matrix, what it is doing. It is actually there are 30 setosa, and all 30 setosa has been classified correctly without any error. So there is zero error. There is zero error. So in our model, 30 setosa has been classified as it is, and 28 versicolor has been classified correctly, but 2 has been classified wrongly as virginica. So this is the classification error. And in virginica, 27 virginica classified correctly, but 3 classified wrongly. So this is your confusion matrix, which tells you how many classified correctly, how many classified wrongly in this data. Okay. Now, if I want to predict our data, so predict new data, test data. We are going to use test data, and out of test data, I am excluding the 5th column because that 5th column is not required. So I am using that classifier which you have developed previously on the new data. So in unexpected error, oh, sorry, I have to run whole line. Then confusion matrix. And now this is the confusion matrix for testing data. So out of testing data, again, setosa has been classified correctly, 100%. Versicolor 17 has been classified, but 3 has been misclassified. In virginica, 19 has been classified, 1 has been misclassified. So even in testing data, it is the case. Now question arises how we plot it. So if we plot it, what it is plotting actually here? When you run this command plot classifier RF, what is it is plotting here? See, it is plotting the error. We have to understand this plot. See, on x-axis we have trees. That means how many trees you are going to use. So you can use 0 tree, you can use 100 tree, 200, 300. So we have used actually 500 trees. So it is giving you the errors. And what are those errors? You can see 4 things here. One is blue, another is green, another is dark green, and one is red. So there are 4 kind of errors. What are 4 errors? If you remember, you have 4 predictors: sepal length, sepal width, petal length, petal width. So it is saying that all the 4 features are stabilizing. Errors are stabilizing here. See, at 500. Actually, they have stabilized at 200 also. If you see, even at 100, they have been stabilized. So even if you use 100 trees, the model will be good. So these are the errors, individual errors related with each feature when you run this random forest. Now question arises, okay, I know that now from this graph you can see blue errors are more in comparison to others, light green is more in comparison to other true, and the red one is the lowest. That means in red one case the error is the minimum. So these are the 4 different features having different errors. So of course the feature which is having less error, that will be the important feature for us. So I want to know the importance of the features. So the command is importance classifier RF. When you run this, it will give you the importance. Now see how we find the importance of a feature. So there is a criteria which is known as Gini index. Some people say it Gini index. I do not know what is the right pronunciation. So I call it Gini index. So Gini index, there is a mathematical formulation of that. I am not going into that. So we focus upon mean decrease in Gini index. So if you use sepal length, it will decrease Gini index on an average by 5.37. If you use sepal width, it will decrease Gini index by 1.63 on an average. Petal length 29 point and petal width with this. Now you can easily understand which one is the good one. Petal length having the highest mean decrease in Gini index, that is having the highest importance. So this is petal length is actually the very important feature. We have to focus upon that, and then we have to focus upon petal width, then we have to focus upon sepal length, then we have to focus upon sepal width. So this was the importance of the classifier. You can plot this also. By plotting, you can see here petal length is on the top, petal width below that, sepal length below that, and sepal width below that. So from here, I have completed the task. So what I have done here, I have taken a data from iris data, and then with the help of iris data, I have predicted the three types of species, whether it is setosa or versicolor or virginica, based upon sepal length, sepal width, petal length, petal width, and then I have seen which feature is more important. But that means which feature have more importance in this classification criteria. So this was done from my